Okay, so Sheldon, you asked a great question. I believe this is problem 100 in chapter 4, and it's writing out reactions, and you asked for part C. So I'm going to go ahead and kind of walk through that. 4.100 C. And what did that say again? Sheldon,
For me, it's a liquid propanol
can
and
you kind of repeat
gaseous
it? Because yours
oxygen.
is different than mine. My book is different. I'm sorry?
Liquid propanol and gaseous oxygen.
What does it say about it to write out the reaction with it?
Yeah, express your answer as a chemical equation and then
Okay.
identify
Oh,
phases.
excellent. Thank you, sir. So liquid propanol and oxygen gas. All righty. So the first thing we need to know is we need to know our organic chemistry nomenclature. So the first thing we need to know is, what does prop as a prefix mean when we talk about the number of carbons in organic chemistry?
Is it 3?
Yes, excellent. Thanks. It's 3. So I know I got 3 carbons, right? What does the all mean? Does anyone know what they eat? What do people drink on the weekends? That was corny, but what do people sometimes drink
Alcohol.
on the weekends? Anybody? Are you guys still out there?
Alcohol?
Yeah. So the all means there's an alcohol. Now, they didn't say two, like there's, just so you know, there's 2 propanol and then there's 1 propanol. They didn't tell you which one. They just said propanol, but we know there's an alcohol. Now, had they said 2 propanol, that alcohol would have to go on carbon number 2. Had they said 1 propanol, that alcohol would have to go on number 1. They didn't specify, so we're not going to really worry about it. I was just showing you that for nomenclature purposes. We just need to get the formula so we can write out the reaction with the correct formula and balance the equation. So I'm going to say that this was just 2 propanol. So what I'm going to do is I'm going to put an alcohol right here. Okay. And what do each carbon, how many bonds do they have to have?
4?
That's right. So this carbon number here, this carbon right here, and I'll just call that number 1. This is 2, this is 3. And carbon 1 and 3 are called primary carbons. That means that they're bound to one other carbon. So they already have 1 bond. So if they need 4, if they already have 1, how many more do they need?
3 more?
Yep. All right. So now we get to carbon number 2. It's called a secondary carbon. Why is it secondary? It's bound to 2 other carbons. And it's also bound to an alcohol. So it already has 3 bonds. How many more does it need?
Just 1 more.
Yep. And there's my hydrogen. So there's propanol. Prop, like you said, 3 carbons, and it's got an alcohol group. So now I'm combining this with oxygen. How do we find oxygen in elemental form in nature?
It's diatomic.
Excellent. It's a diatomic. What does this look an awful lot like? Well, if you watch my videos on the different types of reactions, right? I even put an X and a Y and a Z here to show that they're different numbers. But basically, what do I have here? What do I have right here? What do I have set up? I have a fuel source. I have carbon, hydrogen, and oxygen, which is a fuel source in the presence of oxygen. What type of reaction do you think this is going to be of the 5 basic types? Somebody said it. Who said that?
Me.
And you said what?
Combustion.
Yes, combustion. So what are the two products? Always, always, always.
CO2 and H2O.
Oh, yeah, that's right. Now, to balance this correctly, though, we need to get the right formula. So this is a C3. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, and 1 oxygen. Now we have to have the right states of matter. You said this was liquid, right? Like rubbing alcohol. How do we find oxygen in nature? A gas. Our product, CO2. How do you find CO2 in nature?
It's also a gas.
Yes. And normally we find water in nature as a liquid. However, because combustion reactions release a lot of heat, which is referred to as exothermic, it causes the liquid water to vaporize and I get a gas. Okay, so there we have the formulas. We identify, well, Monique identified this as a combustion reaction because I have a fuel source in the presence of oxygen. So I'm going to produce CO2 and water. What's the last thing I need to do for this problem?
Balance it.
Yup. Now, did you follow my rule? Did you watch the video about the rules for balancing, Sheldon? Come on, man, that was only 2 minutes.
Yeah, I did.
Yes. What's first?
You should find the element
Balance. Who should you balance first?
that the hydrogen, or no, carbon.
The metals, but normally you would balance metals first. There are no metals, so you would then go to non-metals, and carbon would be first. So you're right. Does that make sense?
Yes.
Okay. So if I see this, I would say, oh, 3. So I might go, well, I need to put a 3 here. Correct?
Yes.
And then I said the third rule, you save hydrogen and oxygen for last. If you have both, who do you save for last?
The oxygen.
Yes, because it's a diatomic. Excellent. So I'm going to go to hydrogen. How many hydrogens?
8.
Okay, how many here?
2.
In water? 2. So what do I need to do? I need to put what here?
4.
Yes. So now I go to oxygens. Now, which side has more oxygen? The reactant or the product?
Currently the product.
The product. Okay. So 3 times 2 is how many?
6.
Plus in water, how many? 4 times the 1 right there.
4.
Okay, excellent. So I have 10 on this side, which means I have to have how many on the reactant side?
10.
Okay, so I have 10. Here's a trick. There's 1 in propanol, so I have to subtract 1 because there's 1 in propanol. So I need how many more? 9. What number times 2 is going to give me a 9?
4.5.
Okay, 4.5 decimal form, my friend. You're definitely a younger generation, but that's good. I like it. You got it right. I call it 9 halves. Why? Because if I multiply 2 by 9 halves, the denominator is 1, the 2's cancel, and I'd be left with the 9 I need. So it's 4.5 or 9 halves. Does that make sense?
Yes.
Here's the thing. We don't want these halves. Sheldon, we don't want these halves.
So multiply.
So what am I
everything
going to
by
do
2.
to all of them? Yes, you did watch my video. Thank you. We're going to multiply everything, every coefficient by 2. So my balanced chemical equation is I got my 2. I don't change the subscripts because that's the formula. I only change the coefficients. It's like distributing through the coefficients in a polynomial. then I would box my answer, but that would be your answer. And you could double check it, right? Because 2 times 3 is how many? 6. 6. 2 times 8, 16. What do I have here? 12. Oh, wait, no, I'll start on this side, sorry. Oh yeah, 2 times 8 for hydrogen, 2 times 8, 16, my hydrogens are good. And then go to the oxygens. 6 times 2 is 12, plus 8 is a total of 20 on this side. There's 2 from the propanol, 20 minus 2. I need 18. How do I get 18 from O2? 2 times 9. Does that help, Sheldon?
Yes, that's good. Thank you.
So why do I love this problem? I love this problem because it shows you that we need to know a little bit of organic nomenclature. You need to know what methanol, ethanol, propanol, you need to know some simple nomenclature. And you did, you knew it right away with the prop being 3. You also need to be able to draw some very simple Lewis dot structure. And you already knew how to count the bonds. The carbon wants 4 bonds. And we were able to derive this formula from that. Then Monique was able to identify, based on the fact that the reactants was a hydrocarbon and oxygen, that this was a combustion reaction, and our products were CO2 and water. And then we were able to figure out the phases, because we know that how we find the compounds in nature are either liquid, solid, or gas. And then lastly, we follow those rules, balancing of equations, and the tricks that I showed in some of the harder video problems on balancing this equation. So, does that make sense, Sheldon?
Yes.
All right, we're done with this one. If you don't mind, I'll stop the recording. We might do another recording, but I'm gonna stop this while I wipe this up, and I'll post this on for everybody to watch. So I really thank you for picking that problem.